Next, we'll be discussing section 4.4 and 4.5. Now, before we do that, I'd like to make several comments here from the previous sections. One is about the addition and subtraction of polynomials. Like many things in mathematics, they can be done in more than one way. And you may have noticed in examples 12 and 15, for adding and subtracting polynomials, they add and subtract them vertically. The reason I did not go into that is because in my experience of well over 20 years, I have found that whenever people do vertical addition and subtraction of polynomials, more errors occur than what I taught you in like adding and subtract them horizontally, the way I did it in the video. So on the other hand, if that's your favorite method, go for it. I mean, it doesn't really matter. The results will be the same. So, but again, in my experience, there are fewer errors when people add and subtract them horizontally as opposed to vertically. Just take my word for it, okay? And it's the same thing with the multiplication of polynomials on page 292, example number 7, I believe. And so you can multiply polynomials vertically also, but again, I've seen more mistakes occur in that way than doing it the way I showed it to you. And the last comment concerns the FOIL method, the FOIL method. That is a way to multiply two binomials, and it saves you a little bit of time. The reason I didn't get into that is because it's another way of learning how to multiply polynomials. Well, I'm more in favor of doing one method, get real good at that, instead of trying to remember several methods that might save you some time. So for lack of, so there's no confusion, I only taught you the method where it says multiply two polynomials by multiplying each term of one polynomial by each term of the second polynomial. Just learn that and you'll be fine. So you don't have to try to remember a specific method. Just know the general method of multiplying polynomials and you'll be fine. On the other hand, if the FOIL method is intriguing to you, just remember that only applies to multiplying two binomials. Okay, it does not extend beyond that. And the method that's general goes for any polynomial, a binomial times one with 7 terms or one with 6 terms times 12 terms and so on. So it works for any two polynomials. And if you have 3 polynomials or more to multiply, multiply 2 at a time and then proceed from there. Okay, so with that explanation, in case you were wondering why I didn't cover that in the previous sections, that's the reason why. So when we come to section 4.4 and 4.5, I will do something similar. When you look at section 4.4, it's about factoring trinomials x squared plus bx plus c. So, in other words, the leading coefficient of x squared is 1. Of course, that's implied. It's not written out. Now, section 4.5 is about factoring trinomials with ax squared plus bx plus c with a not equal to 1. Well, in my experience, if I can just teach you what's in section 4.5, when the leading coefficient is not equal to 1, obviously you can factor trinomials when the leading coefficient is equal to 1, as you will see. And also, again, there are different methods. One of the reasons for factoring I didn't get into the reverse, or I will not get into the reverse FOIL method, is it's a lot of trial and error. And I'd rather show you a method that might take a little longer to learn, but once you get the hang of it, you understand it, it's a whole lot easier. Again, you have to trust me with that. So the method that I will teach you is called the AC method, and that's the second part here, factor trinomials of the type ax squared plus bx plus c with a not equal to 1 by the AC method. So that is exactly what we'll be focusing on here for the next few minutes, the AC method. In the previous section, I mentioned, or we talked about factoring by grouping. And I also mentioned that that's a very, very important skill to develop because at the heart of the AC method is factoring by grouping. So let's review that with one simple example. So here we have a polynomial y to the 8th minus 7y to the 7th plus y minus 7. There should be a 7. Sorry about that. Okay, so remember how it goes. We take one group, and here's the second group. And so we factor the greatest common factor from the first group, which is y to the 7th. So we factor y to the 7th. That leaves us a y, or y to the first power, and minus 7. So again, factoring by grouping means the binomial for the second group will also be a y minus 7. So what do we need to factor out from the second group, y minus 7? Well, there's only one thing we can factor out, and that's a 1. And that, of course, is a positive one, because 1 times y is y, and 1 times minus 7 is minus 7. So now, when you look at this expression, the greatest common factor is y minus 7. And then we have y to the 7th, and we have plus 1. So this then is the factorization of this polynomial. So y to the 7th plus 1, y to the 7th plus 1, times y minus 7. So in other words, the factoring by grouping is critically important for learning how to do the AC method. So let's talk about the AC method then. And the 6-step process. Number 1, as always, no matter what method you're using, factor out the largest common factor. Always. Always, always. So the remaining trinomial is of the form ax squared plus bx plus c. And again, we'll go over several examples. Then we multiply the leading coefficient a and the constant c. And again, we'll do this in many examples, and you'll find out what that is. And then we factor the product AC in such a way that the sum of the factors is b, and with the coefficient of x. It sounds a little bit confusing, but again, once you see it, that is, we find integers p and q such that p times q equals ac, the product equals a times c, and the sum of the factors equals b. And then we split the middle term, writing it as a sum using the factors found in step 3. That's p and q. So those are the factors here. And then we factor by grouping, and we just reviewed that. And then step 6, check by multiplying. Step 6, of course, is optional. And if you're totally sure that you're correct, then you don't have to do it. But I would highly recommend you do it, at least in the beginning, and to practice multiplying polynomials, or polynomials in this case. So anyways, these are the 6 steps, and we'll be using those 6 steps every step along the way when we do examples here now. So let's use the AC method on this trinomial, 4x squared plus 4x minus 3. And so step 1 was to factor out any greatest common factor, and there is none other than 1, so we don't need to do that. So then the second step would be to find A, B, and C. And so I always recommend to write down specifically what A and what B is and what C is. Trust me, you do it. You do better. So A is the coefficient, the leading coefficient for x squared, so it's equal to 4. And B is a coefficient of x, so it would be equal to 4. And C is equal to minus 3. And notice the negative sign. It is important, okay? So then step 3 was to compute the product of A times C, which would be 4 times negative 3, or minus 12. So next we want to factor minus 12 in such a way that there are 2 integers p and q, so that their product equals minus 12, and that the sum of P and Q equals B. And remember, B is equal to 4. Now, there are several ways we can factor minus 12. The fact it's a negative number tells us that the factors have the opposite signs. In other words, one factor has to be positive, one has to be negative, or else the product couldn't be negative. And we also notice that since B is positive, that the positive factor has to be greater than the negative factor. So let's think about this. So minus 1 times 12. When we add minus 1 on 12, that gives us 11. So that isn't it. Then we can have minus 3 times 4. Again, the positive factor is greater than the negative factor. But minus 3 plus 4 is equal to 1. So that is not the right one either. Now, when we compute minus 2 times 6, then minus 2 times 6, of course, is minus 12, and minus 2 plus 6 is 4. So that's the one. In other words, P equals minus 2, and Q equals 6. So I won't necessarily show the next step in great detail all the time, but I will show it to you one time. And that is, so now we split the middle term. What that means is this. I'm going to rewrite the polynomial that we are factoring, 4x squared plus 4x minus 3. So 4x squared remains the same, of course. But now we are splitting the middle term. And we're going to write it as minus 2x. Remember, using P and Q as coefficients now. Plus 6x minus 3. And when you look at this expression now, of course, it's the same as above, the equivalent. We have 4x squared, and minus 2x plus 6x is still 4x minus 3. But now we can factor by grouping. And that was the whole reason why we want to split the middle term, so we can factor by grouping. So here we go, factoring by grouping, group 1, group 2. And the greatest common factor of the first group is 2x, because there's a 2 and an x in this term, and there's a 2x there. So we have 2x, and when we factor out a 2x from 4x squared, we get 2x. And then, since the greatest common factor is the term itself, we need to have a 1 as a placeholder, and you can always check that, because 2x times 2x is 4x squared, and 2x times minus 1 is minus 2x. And remember, the good news about factoring by grouping is once you have the binomial for the first group, you know it's the same one for the second group, 2x minus 1. And here's a little trick how to figure out what to factor out. You divide the term with the x by the first term in the parentheses, in the binomial. So 6x divided by 2x, the x's cancel, and 6 divided by 2 is 3. So we factor out a positive 3. Now we look at this expression here, and we notice the greatest common factor is 2x minus 1. That's our greatest common factor. So that's step 5. 2x minus 1 is our greatest common factor here and here. And in the other set of parentheses, and again, there's an implied multiplication, we put the 2x and we put the 3 in there, plus 3. So that then is the factorization of the trinomial that we started out with. And we can check our result. And again, I won't do it all the time for you, but you should definitely do it. You need to practice. 2x times 2x is 4x squared. And 2x times minus 1 is minus 2x. And 3 times 2x is 6x. And 3 times minus 1 is minus 3. So we combine like terms. 4x squared, there's only one of those. And then we have minus 2x plus 6x is 4x minus 3. And that is the original trinomial we started out with. So this is the factorization of a trinomial. Let me put the answer in there. So that's equal to 2x plus 3 times 2x minus 1. There. So here's the derivation of the answer. I'm just going to show it to you again so you can take a look at that. And I would highly recommend you do this on your own. And now you have a comparison. Of course, there's also examples like that in the book. So whatever method or whatever examples you like best. So here it's worked out with steps explained also. And again, I'll do several more examples. The next exercise is a guided solution. So 4x squared plus 37x plus 9. So we multiply the leading coefficient and the constant. So 4 times 9 is 36, right? And so we want to find pairs of factors of 36 so that their product equals 36 and the sum equals 37. Remember, the sum has to equal the coefficient of x or b. So again, I would always suggest to write out specifically what a and what b and what c is. So again, a was equal to 4 and c is equal to 37. B is 37, c is equal to 9. So we want the factors to add up to what? To 37, right? So, and the way it's written here, 1 and 36, of course, 1 times 36 is 36, and 1 plus 36 equals 37. Bingo. So we've got the answer right here. So that's convenient. That's already laid out for you here. Here are the other factorizations of 36, 2 times 18, and 3 times 12, and so on. And anyway, we don't need the other ones. We already have the p and the q. The way we split up the middle term, remember that's what it's all about, to split up the 37x, so we can factor by grouping. So that's the next step. Split the middle term, x plus 36x. Because x plus 36x equals 37x. Then we factor by grouping. So now we rewrote the middle term, 37x as, x plus 36x, and we had 4x squared plus 9. So in the first group, we factor out the greatest common factor, which is x. So we have x times 4x. Remember the placeholder for 1 with 1 for the x. So because the greatest common factor is one of the terms, so you need a 1 for a placeholder. So when you multiply out x times 4x, you get 4x squared, and x times 1, you get x. So that 1 is essential. And so here we factor out a 9, because we already know that has to be 4x plus 1. Again, that's what makes factoring by grouping easy, that once you have the first binomial for the first group, you ought to have the binomial for the second group. It's the same. So now, when you look at what you have so far, you now have x times 4x plus 1 plus 9 times 4x plus 1. So the greatest common factor is 4x plus 1 times x plus 9. So the 4x plus 1 goes here. Obviously, it doesn't matter which factor goes first, right? Because multiplication is commutative, the order of the factors does not matter. And then you can multiply out the 4x times x to get 4x squared and make sure it's the correct answer. And I leave that as an exercise for you. If you multiply these two binomials correctly, you will get the original trinomial 4x squared plus 37x plus 9. Let's look at another one. Factor 6x to the fourth plus 116x to the third power minus 80x squared. And so we notice right away that among the coefficients, the greatest common factor is a 2. So step 1, we factor out a 2. And then among the variables, we have x squared that's common to each term. So we factor out a 2x squared. So that gives us a 3x squared minus 58x minus 20. Minus 40 rather, minus 40. So now we just need to look at this trinomial here, and we'll take care of the 2x squared later on. We remember to use that again to multiply that when we are done with this trinomial here. So right now we are focusing on 3x squared minus 58x minus 40. And so now we identify a, b, and c. A is the leading coefficient. A equals 3. B equals minus 58. And C equals minus 40. So then A times C is equal to 3 times minus 40. 3 times minus 40, and it would be minus 120. So that's step 3 here. And now we want to factor minus 120 in such a way that two numbers p and q, so that the product equals minus 120, and that the sum p plus q equals b, or minus 58. Now the fact that the product is negative means that p and q has to have opposite signs. But because p plus q is negative, it means that the negative factor has to be greater than the positive factor. For instance, we can say, well, minus 320, we can write it as minus 3 times 40. Okay? But of course, then the sum would equal 37, and that's not even the correct sign. So how about 3 times minus 40? That's also minus 120. Now the sum equals minus 37, but it's supposed to be 58. So what else can we do? Well, we can say, how about 2 times negative 60? That's certainly equal to minus 120, and 2 minus 60 is minus 58. So that's a factorization we want. It satisfies both requirements. The product is equal to minus 120, and the sum equals minus 58. So now we're going to, well, I'll do it one more time. We rewrite the trinomial. And the trinomial that we're focused on right now is 3x squared minus 58x minus 40. So we have 3x squared. Now we're going to use 2 and minus 60 to split the middle term. So plus 2x minus 60x. 60 minus 40. So we split the middle term this way using p and q as coefficients. And you notice that 2x minus 60x is minus 58x. So these two statements are certainly equivalent. However, now we can factor by grouping. That's our next step, 5. So here's group 1. And so when we look at that, we can factor out the greatest common factor, which is x. And that leaves us with a 3x plus 2. And here's the second group. Now we know that the binomial for the second group has to be 3x plus 2 also. So 3x plus 2. Now we only need to answer the question, what do we need to factor out? And again, one way to do that is to use this term minus 60x divided by 3x. So the x's cancel, of course. And minus 60 divided by 3 is minus 20. And a quick check says that minus 20 times 3x is minus 60x, and minus 20 times positive 2 is minus 40. So we are good with that. So now we realize that our greatest common factor is 3x plus 2. 3x plus 2. And for the other factor, we have the terms x minus 20. So then for the complete answer, remember that we originally factored out a 2x squared. So then the complete answer would be 2x squared times x minus 20 times 3x plus 2. So that is the answer to the original question or statement factor. So let's write it down here. So that's equal to 2x squared times x minus 20 times 3x plus 2. So by now I'm sure you've recognized the key steps as were explained in the beginning, what the general method is for solving or factoring trinomials using the AC method. Again, no matter what method you use first, if there's a greatest common factor, you factor that out first. And then in our case, we have our trinomial that we focus on for the time being. And we identify A, B, and C. I recommend you always do that in writing. Don't try to do it in your head. The problem is doing it mentally is that people, in many cases, forget that they're minus signs. So do yourselves a favor and write it out what A, B, and C is. Be specific. You can't go wrong with that. And then we formed the product of A times C, and there was 3 times minus 40, 1 minus 120. We looked at various factorizations of minus 120. And then we found out that 2 minus 60, 2 times minus 60 is a proper factorization because the product is minus 120 and the sum equals minus 58, which is B equal to B. And then we just split the middle term, factor by grouping, and then remember to use the factor we factored out in the beginning, 2x squared, for your final answer. And that's it. So it just takes practice. Here's another trinomial that we're supposed to factor. And when you look at it, you realize that y squared is the greatest common factor to each of the terms. There are no greatest common factors among the coefficients. So we factor out, as step number 1, we factor out a y to the second power. So y squared times 10y squared minus 7y minus 12. So then we factor now on the trinomial 10y squared minus 7y minus 12. We identify A, B, and C. A is the leading coefficient of 10. B is equal to minus 7. B equal to minus 7. And C is equal to minus 12. So now we form the product of A times C, which would be 10 times minus 12, or minus 120. And so now we want to factor minus 120 in such a way that the product is equal to minus 120 and that the sum P plus Q equals B, or minus 7. And since the product is negative, one of the factors has to be positive, or one has to be negative. And also the negative factor has to be greater than the positive factor because the sum is negative. So we could say, for example, minus 120 is 3 times minus 40. But then the sum of 3 and minus 40 would be minus 37 and not minus 7. How about 6 times minus 20? Well, again, it would be minus 120, but 6 minus 20 is minus 14. Then we can think about maybe 8 and minus 15. So 8 times minus 15 is minus 120, and 8 minus 15 is minus 7. So that now means that we have found our coefficients p and q that allow us to split the middle term, minus 7y, in such a way that we can factor by grouping. This was step 3. And so number 4, we have our trinomial 10y squared minus 7y, 10y squared minus 7y minus 12. We split the middle term using p and q as the coefficients for the term of y. So in other words, 10y squared plus 8y minus 15y. Again, 8y minus 15y is minus 7y minus 12. Again, these two expressions are equivalent. We just rewrote the middle term. We split the middle term. And now we're factoring by grouping. Here's our first group. Here's our second group. So we notice that 2y is a common factor here. So 2y would be 5y plus a 4. And here that means we have a 5y plus a 4 also. So 5y plus a 4. Now we just need to determine what to factor from the second group. Again, we can use the method I recommended before. We divide minus 15y by 5y. So minus 15y divided by 5y. The y's cancel. And minus 15 divided by 5 is equal to negative 3. So we need to factor out a negative 3. And again, a quick check tells us that minus 3 times 5y is minus 15y. And a minus 3 times a positive 4 is a minus 12. So it means we are good. So now we can factor by grouping in the sense that we have our greatest common factor is 5y plus 4. 5y plus 4. And then for the other center parentheses, again multiplication here, is 2y minus 3. 2y minus 3. And then for the complete answer, remember that we factored out originally a greatest common factor of y squared. So we write that in front here, y squared, implied multiplication. And so this is then our final answer for factoring the above trinomial. And again, step 6, I leave it up to you to check the answer. So that was equal to y squared times 2y minus 3 times 5y plus 4. So all it really takes is a little bit of practice. The next trinomial is 6a to the third plus minus 7a squared minus 5a. And again, among the coefficients, there are no common factors, but for the variable, a is common to each term. So that means step 1 is we can factor out an a. So a times 6a squared minus 7a minus 5. So now we just focus on that trinomial, and later on we write a as a factor in front. So we're looking at 6a squared minus 7a minus 5. So we identify a, b, and c. A is the leading coefficient of 6. B is equal to minus 7. And C is equal to minus 5. And again, always pay attention to the minus signs. That's really critical. Otherwise, you can't come up with the right answer. If you miss one sign, nothing will work for you. Okay, number 3, A times C is equal to 6 times minus 5. 6 times minus 5, or minus 30. So we want to write minus 30 as a product of two integers, p and q, in such a way that the product is minus 30 and that the sum is equal to b, or minus 7. Okay, the sum has to equal b. So how can we factor minus 30? Again, it implies that the factors have their opposite signs, so the product will be negative. And because the sum is a negative sum, that means that the negative factor has to be greater than the positive factor. So minus 30 could be written as 5 times minus 6. So that would be minus 30. But of course, when we add 5 and minus 6, we get minus 1 and not minus 7. Then there would be 2 times minus 15. That would be minus 30 also. But 2 minus 15, the sum of them would be equal to minus 13. That wouldn't work. And then we could have 3 times negative 10. 3 times negative 10 is minus 30, and 3 minus 10 is minus 7. So that is now what we've been looking for. These are the factors p and q that we use to rewrite the middle term of 7a. So let's do that. So then we have step 4, we have 6a squared minus 7a minus 5, so 6a squared, and now we rewrite the middle term as 3a minus 10a minus the 5. So that doesn't change. And again, you notice that 3a minus 10a is equal to minus 7a, so these two expressions are equivalent. But the second expression allows us now to factor by grouping. So in group number 1, we see that 3 is a common factor, and so is a. So 3a times 2a, because that will give us a 6a squared. And since 3a is the greatest common factor, we need a placeholder of 1. So that 3a times 2a is 6a squared, and 3a times 1 is 3a. And since the binomial is 2a plus 1 for the first expression, it has to be 2a plus 1 for the second expression. So how do we know what to factor out? We use minus 10a and divide that by 2a. The a's cancel out. And minus 10 divided by 2 is equal to minus 5. So we need to factor out a negative 5. Quick check. 5 times minus 2a is minus 10a. And 5 times 1 is minus 5, so we're good. And so now our greatest common factor is 2a plus 1. 2a plus 1. And in the other set of parentheses, we put in the 3a minus 5. 3a minus 5. And then remember, when we first factored out an a, the greatest common factor in the very beginning, so that has to be now the factor here. So in other words, the final answer is a times 3a minus 5 times 2a plus 1. So let's write this up here as a solution. A times 3a minus 5 times 2a plus 1. Now when you do this on your own, let's say a particular problem that I did, what may happen is, because depending how you write the factors here, that these two factors may be interchanged in their order. And remember, it's always multiplication. But that's the only thing that might be different about the answer. But again, since multiplication is commutative, which means that the order of the factors does not matter for the final answer, whether you write it in this order or the different order, it's mathematically the same. Let's do the next exercise here. 18y to the third minus 3y squared minus 10y. And we notice that there's a greatest common factor of y. So step 1 is we factor out a y. So y times 18y to the second minus 3y minus 10. So now we're going to focus on the trinomial 18y squared minus 3y minus 10, and we identify a as 18, b is equal to negative 3, the coefficient of y, and c is equal to minus 10. Then we form the product of a times c. In other words, 18 times minus 10. Which would be minus 180. And we are looking for a factorization of 180, two numbers, p and q, two integers, so that their sum is equal to b, and b was equal to negative 3, and that the product is equal to 180, a times c. When we factor minus 180, again, one factor has to be positive, one has to be negative, so the product is negative. And also, since the sum is negative, that means the negative factor has to be greater than the positive factor. So, so minus 30 times 6 is certainly equal to minus 180, but the sum of minus 30 plus 6 would be minus 24. So that is not what we're looking for. Then we can say minus 20 times 9. That's all, the product is also equal to minus 180, but minus 20 plus 9 is minus 11. So that's not what we're looking for. And we could say minus 18 times 10 would also be minus 180, but the sum would be minus 8. So how about minus 15 times 12? See how that works. Minus 15 times 12 is minus 180. And minus 15 plus 12 is equal to minus 3. So here then is the numbers we're looking for to rewrite the middle term. The middle term of this trinomial here. So here it is, the trinomial, step 4, 18y squared, rather, minus 3y minus 10. So you're going to rewrite the middle term is minus 15y plus 12y. And we have our 18y squared here, 18y squared, and our minus 10. So now we can factor by grouping. And we can factor out a 3y. greatest common factor for the first group. So we get a 6y minus 5. 6y minus 5. So in other words, for the second group, we have to have a 6y minus 5 also. So what do we need to factor out? Well, we have 12y. We divide 12 by 6y. 12y divided by 6y. The y is cancelled. 12 divided by 6 is 2. So we need to factor out a 2, a positive 2. Quick check. 2 times 6y is 12y. And 2 times minus 5 is minus 10. So that works. So our greatest common factor is 6y minus 5. 6y minus 5. And then for the other parentheses, we have the 3y. And we have the 2. And remember, originally we factored out a y. So that would be another factor here for the final answer. So what's step 5? So let's write down our final answer. So it's equal to y times 3y plus 2 times 6y minus 5. In the next example, 10y squared plus 23y plus 12, we notice there's no greatest common factor. To step 1, there's nothing to do. Step 2, we look at 10y squared plus 23y plus 12. We identify A as 10, B is equal to 23, and C is equal to 12. Step 3 is the product of A times C, which would be 10 times 12, which would be 120. And so we want to factor 120 in such a way that P times Q is equal to 120, and P plus Q is equal to 23. So different factorizations, and we notice the product is positive and the sum is positive, so both terms are positive. So 120, we can multiply that factors as 10 times 12, but 10 plus 12 is 22 and not 23. We could write 4 times 30. That's 120, but the sum is equal to 34, so that doesn't work. This was 22. Not 23. And then there's maybe 8 times 15. And 8 times 15 is equal to 120, and 8 plus 15 is equal to 23. So here's what we're looking for. That means we can rewrite our middle term using P and Q, that's 8 and 15, to split up the middle term. So step 4. We write 10y squared plus 23y plus 12. And we rewrite the middle term now using 8 and 15 plus 8y plus 15y plus 12. And again, notice that these two expressions are equivalent, since 8y plus 15y is 23y. And now we can factor our first group and our second group. And in the first group, we notice that 2y is the greatest common factor. So 2y, that'll give me a 5y plus a 4. So in other words, that is the binomial for the second group also, 5y plus 4. And what do we need to factor out? Well, we divide 15y by 5y. 15y by 5y. The y's cancel, and 15 divided by 5 is 3. So that's what we need to factor out. So the positive 3. And now our greatest common factors is 5y plus 4. So 5y plus 4. That's our greatest common factor. And then for the other parentheses, we have 3, and we have a 2y. So this then is our factorization of the original trinomial. So let's write that next to it as the answer. So we have 2y plus 3 times 5y plus 4. As you can see, it's all fairly repetitive, and in order to get some proficiency on that, all it takes is some practice. Let's do the next example. Step 1 is there's no greatest common factor among the coefficients or the variables. So we just need to focus on 9x squared minus 30xy plus 25y squared. So A equals 9, B equals minus 30, and C equals 25. So then we form the product of A times C. So it would be 9 times 25. 9 times 25, that's equal to 225. And now we want to factor 225 in such a way that the product is 225 and the sum, P plus Q, is equal to minus 30. Now, the product has to be positive and the sum has to be negative. That means that both factors have to be negative. Unless both factors are negative or both positive, the product could not be positive, but they have to be negative so that the sum could be negative. So there would be well, one thing comes to mind would be minus 15 times minus 15, because 225 is a square. And let's see, minus 15 times minus 15 is 225, and minus 15 plus minus 15 is minus 30. So we use minus 15 and minus 15 to rewrite the middle term of minus 30xy. So let's do that. So then we have 9x squared minus 30xy plus 25y squared. So we split up the middle term. So we have 9x squared minus 15xy minus 15xy plus 25y squared. So now we can factor the second group, and we can factor the second group, factor by grouping. In the first group, we can factor 3x as the greatest common factor. So there would be 3x minus 5y, because take a 3 out of 15, it leaves it at 5, and then there's a y, minus 5y. So that means for the second group, the binomial needs to be 3x minus 5y also. What do we factor out? Well, we divide the minus 15xy by the first term here, which is 3x. So the x's cancel, and 3 against minus 15 is minus 5, and then there's a y, so minus 5y. So we need to factor out minus 5y. Let's check, see if that works. Minus 5y times 3x is minus 15, xy. So that gives me that term again. And minus 5y times minus 5y is 25y squared. So that's the correct factorization from the second group. And now we realize that 3x minus 5y is our greatest common factor for both terms. So then for the other set of parentheses, we have 3x minus 5y. And, of course, that's equal to 3x minus 5y to the second power. So that would be, or that is the answer to this problem here. So it's 3x minus 5y raised to the second power. Here's the last example, and I brought that in for a particular reason. So step 1 is there's no greatest common factor to factor out. Step 2 is we have 4t squared plus 9t minus 6. So we identify a as equal to 4, the coefficient of the t squared, and b would be the coefficient of t, which is 9. And c is our constant term, so c is equal to negative 6. And then a times c equals 4 times minus 6, so 4 times minus 6, or minus 24. Now we want to factor minus 24 in such a way that the sum is equal to 9. So P and Q. And since the sum is positive, and one term has to be positive, one has to be negative, we also know that the greater of the two terms has to be positive. Otherwise, the product could be negative, and the sum couldn't be positive. So what do we have here? Well, we could have 12 times minus 3 times minus 2 rather. That's negative 24. But P plus Q, the sum, is equal to 10. Or we could have 6 times minus 4. That's also minus 24. But the sum then would be equal to 2. And as we go through these factorizations, like 8 times minus 3, again, the product is minus 24, but the sum is equal to 5. And that's pretty much it, because the next factorization would be negative p times positive q, in other words, minus 12 times positive 2, but there would be a negative sum. So what happens now is that you say, okay, I cannot factor minus 24 in such a way that the sum of the two factors is equal to positive 9. In other words, we cannot factor this trinomial using the AC method. In other words, we cannot factor this trinomial over the integers. And so this is what I like about the AC method, even though the book doesn't really get into that. But this is a prime polynomial. In other words, it's a polynomial that cannot be factored. Which shouldn't be too much of a surprise, because remember in the beginning I said that polynomials are a lot like integers. And you know that there are a lot of integers that can be factored. Like we've looked at lots of examples, like 120, and they can be factored into 3 times 40 and in different ways. But there are certain numbers that cannot be factored into non-trivial factors like 1, and the number itself, like 17, is a prime number. So there are quite a few prime numbers, in fact there are infinitely many, and there are also prime polynomials. So it can happen that a polynomial cannot be factored, and in that case it's a prime polynomial. So I thought I'd leave that with you, and you can think about this a little bit, and maybe if you have any questions about it, we can discuss it also maybe during office hours. So the key to success to factoring is really, especially trinomials, is lots of repetition, and there are many examples in the book where you can practice, and you can also, of course, use the examples I used here. And but again, practice is the key to getting real good at this. And so I wish you the best of success.